Hello students, welcome to Mission Design 1. We are in second module. In the previous videos, we have solved certain problems using instantaneous center method. In the last video, we have solved one problem using relative velocity method. Now we are going to solve another one problem using relative velocity method. We are going to find the velocity of the given links using the relative velocity method. Let us read the question first. So from this figure, it is a toggle mechanism. Okay, in this toggle mechanism, D is constrained to move in horizontal direction. That is, this D is a piston, so piston will move only in the horizontal direction. For the given configuration, find out velocities of points D and angular velocity of links AB, BC, BD. So first of all, we have to find out the velocity of this piston. Okay, velocity of this piston we have to find out. We have to find out the velocity of this piston. Okay, this piston is moving front and back, and then we have to find out the angular velocity of link AB. So angular velocity of link AB, BC, BD. Okay, and they have told that this OA is a crank and this crank is rotating at 60 rpm. This crank is rotating at 60 rpm in the counterclockwise direction. In the counterclockwise direction. So they have given the dimension. We have to draw the diagram according to the dimension. What we can do, uh, we can fix this point. We can fix this point, or we can fix this point, either one. Okay. Whether they given the angle? No, they didn't give the angle. So we have to fix this point in the take your drawing sheet and in the lower left corner around this place. Okay, in the lower left corner. First of all, we have to draw this space diagram, then only we can draw the velocity diagram. To draw this space diagram, you can fix this space diagram, particularly point C, in the lower left corner around this place in your drawing sheet. Okay, if this is the drawing sheet, you can fix the diagram at this place. Okay, particularly point C. Okay, first of all, mark point C. Okay, mark point C, and then draw a horizontal line. Draw a horizontal line. Draw horizontal line. Then horizontal reference line. It should be a thin line, not a thick line. Very thin line. It should be visible only to you. We are drawing this line for the reference purpose, so it should be very thin. Okay, so first draw this horizontal line. Then take 300 mm. 300 mm means 30 centimeter. But if you take 30 centimeter means you can't draw that in your drawing sheet. It will be very big. So we have to scale it. How we can scale it? Better we can scale like this. How means? Scale like 1 centimeter equal to 1 centimeter equal to, for space diagram. Okay, for space diagram I am giving the scale value. 1 centimeter equal to 50 units. Like this you scale it. So you have to scale first. One centimeter equal to 50 units. So 300 mm means 300 mm means how much centimeter then? 300 divided by 50. Okay, 300 divided by 50. How much will come? 6. So this height will be 6 centimeter. This will be 150 means 1 centimeter is 50 units. So 150 means 3 centimeter. 300 mm again 6 centimeter. 300 mm 6 centimeter. 500 mm 10 centimeter. Okay. So after drawing this horizontal line, uh, take 6 centimeter and draw one more horizontal line above this horizontal line. Okay. First draw this horizontal line and fix a point C. Okay. First of all, fix a point C and draw horizontal reference line. Then above this horizontal line, 6 centimeter above this horizontal line, one more reference line. One more reference line you have to draw. Okay, one more reference line you have to draw. Then 80 mm. 80 mm means how much? 1 point 1.20. 1 point 1.6 1.6 centimeter. So you have to mark one more point O, that should be 1.6 centimeter away from 1.6 centimeter away from C. Like that you have to mark a point. Okay. Then take 6 centimeter in your compass. Take 6 centimeter in your compass and make an arc. Make an arc. Okay. Take 6 centimeter and make an arc. Okay, 6 centimeter and make an arc. Then you have to draw 10 centimeter. Okay. Uh, you have to the scale should be here. One end of the scale should be here. That should show the reading 10 centimeter. Another end should be 0. It will be 0. That should be here. Okay. 0 should be cut this line. 10 should be cut this line. Like that you have to keep the scale. So we will get point B. So we will get point B. Then 6 centimeter on the compass. Take 6 centimeter on the compass and put an arc here. Put an arc here. Okay. Similarly, take 3 centimeter on the compass and keep it here. And keep it here and put the arc here. Put the arc here. So you will get point A. So now we have drawn this space diagram. Okay. Now we have drawn this space diagram. Now we have to draw the velocity diagram. So here I have put the step-by-step procedure. First we have to draw the space diagram. So already we have drawn the space diagram. Next step we have to find the velocity of A, because they have given the speed, crank speed. They have given the crank speed. Crank speed is 60 rpm. They have given the crank speed. Crank speed is 60 rpm. Based on that, we can find the velocity of the link OA. Okay, first they given the crank speed, that is speed of OA. using that, angular velocity equal to 2 pi n by 60, 2 into pi into 60 divided by 60. So angular velocity is 6.28. uh, velocity velocity equal to velocity equal to velocity equal to angular velocity into distance. What is the distance? OA. Distance OA. So velocity equal to angular velocity is 6.28 and length of OA is 150 mm. 150 mm means here we have to write it in meter. Okay, 150 mm means 0.15 meter. So velocity is equal to 0.942 meter per second. So we get the velocity of link OA. Okay, since O is a fixed link, we have to mention only A. Okay. So we got velocity of the link OA. Now we have to draw the space diagram. Sorry, now we have to draw the velocity diagram. Okay, now we have to draw the velocity diagram. What are the fixed points? O is a fixed point, C is a fixed point. Okay, then this guide is the fixed points. Okay, we have three fixed points. Okay, so mark the fixed point first. Mark the fixed point first. You can draw this diagram in the right side. Okay, right bottom side of the drawing sheet. You can draw this diagram. It will fit inside. Okay, so first of all, mark point O comma C, all the fixed point. This is a fixed point, this is a fixed point, and this guide is a fixed point. So everything will be mentioned as one point. Okay, first we have to mark O comma C. I will tell you once again. Listen carefully. In the velocity diagram, velocity diagram, for all the fixed links, you have to mention only one point. Single dot. Okay, va? If it is a crank or connecting rod or lever or connecting rod, if it is connecting rod means you have to draw connecting rod or lever means you have to draw perpendicular line. Okay, perpendicular line like this. Perpendicular lines. So perpendicular line for this link is okay. So it will be velocity line of A. It will be velocity line of, it might be in any direction. It might be in any direction, up and down, any direction. We don't know that. After finding answer only, we will know about it. V, A, B. Similarly here, this also we don't know at just a perpendicular line. I don't know it will be on which direction. V, B, B. For piston it will be along the, it will be parallel line. For piston it will be parallel line. For piston parallel line, but for other links you have to draw perpendicular line. Okay, perpendicular line like this. This is perpendicular. This is also perpendicular line. I don't know on which side it will be, but it will be like this only. Since crank it is rotating in the upward direction, that is anti-clockwise direction, I know it will be towards the upward side. But for other remaining links, I don't know on which direction the velocity line will be. Okay, but it should be a perpendicular line. Velocity line should be a perpendicular line. Okay, va? See, I am drawing these lines for reference purpose. Okay, you don't want to draw this these lines on the diagram. Okay, this is for understanding purpose. I have drawn this line. Okay, so for all the fixed links you have to mention one dot. Remaining links it should be perpendicular line. For piston it should be parallel line. Okay, so I know the velocity of OA 0.942 meter per second. So here also I have to do scale. I am going to do the scaling now. How I am going to scale it means I am going to keep 1 centimeter as, because 0.9 means very small. So 1 centimeter equal to 0.1 meter per second. Okay. So 0.942 meter per second means you have to draw 9.4 centimeter line. You have to draw 9.4 centimeter line. Okay. See, scaling is your choice. You can keep 1 centimeter equal to 0.1 meter per second, or you can keep 1 centimeter equal to 0.5 meter per second, or you can keep as it is. But that is your choice. Okay, wow. But I am telling, if you choose the scale like this means the diagram will be somewhat larger and it will fit inside the sheet and you can find out the answer easily. That's why I have fixed the scale as 1 centimeter equal to 0.1 meter per second. Okay, va? So first you have to draw this line. You have to draw this line. See, you have to draw a line perpendicular to OA. You have to draw a line that should be perpendicular to OA. Perpendicular to OA, and that should be in the upward direction. So I have drawn this line from from O to A. Okay, va? O to A in the upward direction. So the line length is 9.4 centimeter. So I have drawn a line that is perpendicular to OA. Perpendicular to OA, I have drawn this line. The length is 9.4 centimeter. Okay. Next, after A, after A, what is the link after A? After A, AB is there. Okay. So we are going to draw a perpendicular line for AB. We are going to draw this line, this perpendicular line. Perpendicular line for AB. Okay. So draw this line. But I don't know it will be on which direction. You just draw it. You just draw it. Draw it on both the sides. I don't know the length. You just draw this line. Okay. So we have completed O A. Up to this we have completed. We have drawn next line that is perpendicular to AB. Okay. Next I am going to take this link. I am going to take this link. This line. This line starts on C, end on B. Okay. This line starts on C, end on B. Where is C here? C is a fixed point. So take this line. See, take this line and draw it. Okay. So this line CB connects with the AB. So here also CB, AB. So connected here. Erase the remaining lines. Erase the remaining lines. These are all remaining lines. Erase it. Okay. So now we have drawn OA, AB, BC. Next BD. Next we have to draw this line BD. So draw a perpendicular line for BD, and from where it is starting on B and ending on D. So it should be start here. Okay, draw the line. I don't know it will be on which direction. So draw line on both sides. Draw a line on both sides. Just to draw the line. I don't know where it starts and I don't know where it ends. Okay, this is BD line. This is BD line. I don't know where it starts and where it ends, but I know it's a BD line. Okay, next. Next one is a slider. Next one is a slider. Next one is a slider. Slider D. Okay, slider D. sliding on the fixed link. Slider D sliding on the fixed link also connected on BD. Slider D sliding on the fixed link also connected on D. So where is the fixed link? Fixed point. This is fixed point. And for slider you have to draw the parallel line. Draw the parallel line. And these two lines, BD line and slider line, cuts on D. Okay. So now we can erase the remaining lines. Slider line and BD line cuts on D. Erase the remaining lines. So we got the velocity diagram. That's all. Now we will go back to the question and let us see what are the things we have to find out. So we have to find out velocity of the slider D. We have to find out the velocity of slider D. Then we have to find out angular velocity of EB, BC, BD. Okay. Now we will come to the answer. You measure this distance OD. Before that, what is the scale we have used? What is the scale we have used? We have used 1 centimeter equal to 0.1 meter per second. 1 centimeter equal to 0.1 meter per second. So whenever you measure the distance from this diagram, you have to multiply that distance with 0.1 because that is a scale. If you measure the distance of OD means you have to measure the distance and you have to multiply it with 0.1. For example, if you are measuring the distance of OB means you have to multiply that with 0.1. Whatever the distance you measure, you have to multiply that distance with 0.1. So here O2D length is 4.1 centimeter I am getting. O2D length is 4.1 centimeter. That means 4.1 into 0.1. What is the answer? 4.1 into 0.1. The answer is 0.41. So that is the velocity of link VD. That is piston. That is the velocity of the piston D. Okay, that is the velocity of piston D. So write it here. VD equal to 0.41 meter per second. One answer is over. Similarly, you measure the remaining distance between AB. Distance between AB. AB is 2.2 centimeter. Okay, distance between AB is 2.2 centimeter. So 2.2 into 0.1, 0.22. Then BC. This BC distances I got 9.1 centimeter. So 9.1 into 0.1, 0.912. Then BD. BD distance is 8.9 centimeter. 8.9 into 0.1, 0.89 meter per second. Okay, so I got all the velocity value. I have to find out the angular velocity of AB. Okay, so we know that velocity equal to angular velocity into link length. Similarly, VBC equal to angular velocity of VC into link length of BC. Then VBD angular velocity of VD into VD. Now we know the VAB answer. So write it here. Angular velocity we have to find out. AB. AB value is 300 mm. You have to write everything in meter per second. Meter. Okay. So 300 mm means here you have to write 0.3 meter. Here you have to write 0.3. Instead of AB, you write 0.3. So you will get the answer for omega AB. Omega AB equal to 0.73 radian per second. Similarly, VBC. So write VBC is 0.912. VBC is 0.912. Omega BC we have to find out. BC. BC length is 300 mm. 300 mm means you have to write 0.3 meter. Okay, 0.3 meter. So you will get the omega BC value. Omega BC value is 3.04 radian per second. Similarly, omega BD. First of all, BBD value is 0.89. Omega BD we have to find out. BD value is 500 mm. 500 mm means you have to write 0.5 meter. Okay, so 0.89 divided by 0.5, you are getting 1.78. Okay. So this is very simple. Solve this problem. In the next class, we will solve another one problem.